Bismillahirrahmanirrahim. Welcome to Physics Department, Bagh School. This is lecture number 14, and in this lecture we are going to understand and analyze the next two MCQs. MCQ number 31. A constant potential difference is applied between two horizontal metal plates. A charged oil droplet is held stationary by the electric field between the plates. This has been illustrated in the diagram. This is charged oil droplet that is held stationary between these two horizontal metal plates. The question further says, as some of the oil evaporates, the droplet loses mass and starts to accelerate. Its charge remains constant. In which direction does the droplet accelerate, and which change needs to be made to the separation of the plates in order to stop this acceleration? Students, basically this charged oil droplet was held stationary because of equal forces acting on the droplet. Upward electrical force was being balanced by the downward gravitational force acting on the droplet. But when the droplet lost some of its mass, it means that its weight was reduced, so electric force became greater, due to which it started accelerating, and it started accelerating in the upward direction. And the next part of the question is that what needs to be done in order to stop this acceleration. In order to stop this acceleration, the separation of the plates need to be increased. Students, we know that the formula to calculate electric field strength, that is E is equal to F over Q. So in order E is equal to V over D. For uniform electric field, it is E is equal to V over D. In order to reduce electric field strength, the separation of the plates need to be increased, and when electric field strength is reduced, electric force is reduced, due to which acceleration is going to be reduced, or this accelerating electron or this accelerating droplet is going to stop. It means that option D is correct, in which it is told that direction of acceleration should be upwards and separation of the plates need to be increased. So option D is correct. I hope it is clear to you. MCQ number 32. An electric current I is given in the list of formula on page 3 as I is equal to A and BQ. Page 3 means was the starting page where the formula and the data values are given. So it means that this formula is also shown on that page. The question further says, what do each of the symbols represent for an electric current in a metal wire? We know that this I is equal to A and BQ. This is the formula for the current flowing through a conductor, where I is the current flowing in the conductor, A is the cross-sectional area of the conductor, N is the number density or number of charge carriers or number of free electrons per unit volume, V is the average speed of the electrons, and Q is the charge of the electron. According to this, where A is the cross-sectional area, repeating it again, A is the cross-sectional area, N is the number density or number of charge carriers per unit volume or number of electrons per unit volume, V is the average drift speed of the charge carriers or the electrons, Q is the charge on the electron or the charge carriers. According to this, option B is correct, where A is denoting area of cross section, N is denoting number of free electrons per unit volume, V is representing average drift speed of electrons, and Q is representing the charge of each electrons. It means that option B is correct. I hope it is clear to you. Thank you. Allah Hafiz.